Okay, it's a new day and it's time to quickly test the cap charger and the logic board before the full systems integration test. Oh wait, what's that whine? That's not supposed to happen. I have a good idea about where it's coming from. If we probe the reset line, we can see that the voltage feedback loop is sending spurious signals to the 555 oscillator and allowing only a few pulses at a time to get through. Looks like I'm going to have to lose the voltage feedback by getting rid of this resistor. It's not a problem since the opto can still signal the logic board to stop charging. Trying again, and that's already a lot better. Now that the caps are charging quickly, we can concentrate on getting them discharged. I'm tempted to unleash the 30 joules of energy since it's been a long time. That is a force to be reckoned with. You can see the damage on the capacitor bank. Some of the solder vaporized and was deposited on the PCB. If that happens to the insides of the railgun, current will be diverted around the projectile, so that is something to note. For a start, let's get rid of the DuPont connectors. Here's the compact version. I've connected the boards together using some 27 EWG copper wire. And just like that, it's done. This is the railgun in its most compact and complete form since August 2016. Of course, it's not fully done yet, that'll take some time. Now, I'm confident enough to plug in a fully charged LiPo battery without a meter. As tradition dictates, today we'll be destroying some aluminium foil. Just like last time, it takes 3 attempts to do this simple job. Now all I need to fire this thing is a support plate, if that's what this is called, to hold the rails together. Since my prime contractor is kind of delaying a little bit, let's look at a few other things. Here's a list of improvements I decided to make to the railgun. First, the current transformer. I tested it with 50 volts, but the output was only around 500 millivolts, so that idea was ruled out quickly till I found a better way to do it. Second, a new kind of projectile. This was inspired by a pantograph. It can vary its width to make better contact with the rails compared to a U-shaped projectile. This requires soaking copper braid in solder, careful measuring, folding, soldering, more soldering, and beating to create a smooth surface. And of course, two stages. I'm using 12 AWG wire now. Its resistance can be found out by passing a constant current through it and measuring the voltage drop. This works out to around 0. About the lubrication, I wanted to use graphite powder, but after two failures trying to buy some from Amazon, I am not sure about this one. Now that we've come this far, it's time to celebrate with some fruit soda, of course.